So here we are at 3t, the limit as x approaches infinity of this particular expression. Now, again, just kind of using that shortcut is something that we can definitely use. If you try direct evaluation, it just doesn't quite work because you get infinity over infinity. So that's not gonna end up working out here. Now, there's a couple options that you can divide by, and I think actually for this video I'm going to show both. So I'm going to go ahead and divide, again, just using that shortcut. Looking at those highest degrees, I'm just going to go ahead and divide first by x. All right, so we're going to divide the entire top by x and the entire bottom by x. So if we do that, again, just using the shortcut, so just looking at the highest degrees, we have x over x. We don't really care too much about this other crap. Over 2x squared over x. And so when we do that, we have the limit as x approaches infinity of, really these x's just cancel out and leave us with 1 over 2. And then on the bottom, we end up with an x just 1 left over, because this x would cancel out with that x on the bottom. And so we're just left then with the x still. Now, if you think about it, we have the limit as x is approaching infinity for this particular expression. Now, if you were to plug infinity in, you'd pretty much just have 1 over infinity. And that's actually just going to approach the limit of 0. Again, just because your bottom's getting really, really large. You have 1 over some really large number, so that's just going to approach that limit of 0. Now, the other method I'm going to use is, instead of maybe just dividing it by x, I'm going to try dividing it by x squared. So we'll do that one in green. So when we do that, we have the limit as x approaches infinity. Again, this is just another option that you can do. The red was perfectly acceptable. So on the green, we have x over x squared all over 2x squared over x squared. Now, the reason I would do that in kind of showing this video is then if you actually go ahead and simplify this, we end up with a limit as x goes to infinity of, we end up canceling this x, so there's 1 left over on the bottom. So we have 1 over x over, these x squareds end up dropping out, leaving us with just 2. And then all we have to do from there is go ahead and plug in that limit. Well, if you plug in the limit for this top piece, you have 1 over infinity. You'd have 1 over infinity. On the bottom, you'd still have that 2. Well, 1 over infinity, again, is just 0. And then you still on the bottom end up with 2. And then 0 divided by any number, it doesn't really matter what it is, just comes out to be 0. So you can kind of see that we did 2 different approaches for this particular problem, and yet we ended up with the same exact solution. So again, as you're doing these limit problems, there's maybe not necessarily one perfect way. Like, different people can do different things and they still end up with the correct limit. You know, that's acceptable. From the summer packet.